Okay, in the last part, just want to briefly describe what is the ideal voltage amplifier model. So you know that the voltage amplifier in the model, it has many parameters. One of the three main parameters is input impedance. We have Zi, and then we have output impedance Z out, and then we have the gain AV. Okay, so for the ideal case, we want the voltage amplifier to have infinite input impedance. So why we want to have the infinite input impedance? Because if the Zi is infinite, so the input of the amplifier will equal to the supply voltage. So how we can prove that is, you know that Vi is equal to Zi over Zi plus Rs Vs, and then we can do some analysis. This is 1 plus Rs over Zi Vs, and then if Zi is infinite, so this part will equal to 0, and then lastly you got Vi is equal to Vs. So means there is no loss at the internal resistance. Okay, and then the second is zero output impedance. So if zero output impedance, so the VL will equal to AV OC V in. So means that the produced output voltage will all go to the load. So will be consumed by the load. So there is no voltage drop at the output impedance because there is no output impedance. And then the third one is infinite voltage gain. So this is the ideal part. That not much to explain about this statement, because amplifier, we want to amplify the signal. If you have the higher gain, so this is better. And then the fourth, next is infinite bandwidth. As I mentioned in the previous part, the amplifier, the operation is limited by the frequency of the signal. So ideally, in ideal voltage amplifier, we want the amplifier to be able to amplify the signal regardless of the frequency, whether this is fast signal or slow signal. And then next is a zero output offset voltage. So this is more on the actual practical. So usually the amplifier will have the output offset voltage, where the 0 volt output with the 0 volt applied at the input. Okay, so this statement will not be discussed in detail. So this is just for your information. And then the last one is no drift in this parameter when the change in the temperature occurs. So this is in terms of the stability of the circuit. Okay, so the last part is the exercise. So determine the value. Let's consider this. This is a voltage model, voltage amplifier model. So the Z in is 800 ohm, and then the Z out is 300 ohm. AVOC, AVOC is 400. Okay, what is AV? So AV is defined by VL. Let's define the AV by VL over V in. Okay, VL over V in. So what is VL? Okay, so how you can do this analysis? You know that AV is VL over V in. Okay, VL over V in. Okay, so one of the approach or the step to calculate this one is by define what is VL. So what is VL? VL is here. What is VL? VL, you can use the voltage divider as a function of a VI. So VL is RL over RL plus Z out AVOC V in. Okay, and then now you can insert the value here, 3K, 300, 400. So this is 3 kilo ohm, 3 kilo ohm, 300, and then this is 400 times V in. Okay, so this okay, 3 over 3.3 times 400. So you get this 363.6 VI. So now VL over VI is equal to 306. So this is the answer for AV. Okay, this is the first answer. Okay, next is AVS. AVS. So AVS is defined by VL over VS. So AVS is VL over VS. Okay, so here you can start with the VL equation, but another way to do is you can redefine what is VL over VS. VL over VS is VL over VI times VI over VS. So this is the equation. Okay, so you know VL over VI is AV. So next thing to do is you need to get the what is VI over VS. Okay, what is VI? VI is the voltage divider at the input part. So input part is we have the Z in over Zi plus the signal resistance Rs Vs. So here Zi is 800, Rs is 50 ohm. So 850, 800, and then you have 800 plus 50 Vs, and then now you get Vi over Vs is equal to 800 over 850. 800 over 850, 0.89. Sorry, 0.94. Sorry, 0.94. Okay, so now you can get this one is 363.6 times 0.94. So the answer is 363.6. You should get 342.2 volt. Not volt, Okay, this is not volt, so this is mistake because this is gain, no dimension. So this is the second answer. Okay, and the last one, the VI is VS is VI and VS is VL is 4.11. Okay, VAC, is VS VL is 4.11, So the equation is VL is equal to 4.11 VAC. Okay, so what is the question is what is VI? So you need to search what is the parameter that relate VL and VI. It is AV. So AV VL over VI is equal to 363.6. So here the VI is equal to VL is 4.11 over 363.6. So you got the answer is 4.11 over 363.6. 0.011. Okay, next, what is Vs? So what is Vs? Vs, the parameters that relate the Vs and VL is AVS. Okay, AVS is 342.2 equal to VL over Vs. So Vs is equal to VL is 4.11 over 342.2. So Vs is equal to 4.11 divided by 342.2. So 0.012 VAC. Cool. So now you can get the answer.